So welcome everyone to this Tech Talk. This is the first episode of the Tech Talk, and this is something new we do for 2021. Hopefully we're going to do a couple of ones every month. So welcome. And I want to make sure I'm introduce our panel today. So Ole, if you change slide, please. So we have Ole Petter from Cloudian here, who is the tech expert on Cloudian storage. We have me, who is a technical pre-sale for Cristie, and we have Johan Tam, who is our moderator and might make sure we overview all the questions that comes in during the presentation. So Ole, next slide, please. So a little bit, short guidelines during the presentation to just make sure we answer all the questions and everything. So basically everyone will be anonymous on this call or on this presentation to just make sure we're not exposing a person. And another thing is that we will mute everyone, so everyone will be muted. And all the questions, please ask them in the Q&A session that you probably see on your right side. And we will summarize all the questions end of each section. So we summarize all the questions. That's going to be the same question over and over again. So next slide, please. A little bit short. So today's topic, we will cover something we call Cloudbrick Tier 2. And Cloudbrick Tier 2 is our private cloud solution that you can have on-prem. And this is typical S3 interface that is supporting modern workload, also multiple backup softwares, and also warm technology for most of the backup softwares out there. That is brief overview, but we want to go deep dive into it. So next slide, please. So this is our agenda. So first of all, a basic overview. So what is actually object storage? What is S3? And after that, we started, how can I start with a POC of S3 and object storage? And how can we scale that POC to a small production environment and then scale out from a small to enterprise lookalike environment? And in the end of this session, we will also go through a little bit security. But this is just sort of brief security topic, because next Tech Talk will be deep dive into application and security in your object and S3 storage. So Ole, next slide, please. And from here, I want to give over to the talk to you, Ole. So go ahead, Ole. Please give you a brief overview how it works.
Yeah, thanks, Christian, and hello, everybody. So to start off, we're going to talk a bit about S3, different kind of workloads that we are aware of S3 uses today, and also a bit where Cloudian comes into the picture, how we solve this problem or need for S3 object storage. So first off, we're going to look at some of the use cases, and one of the real big use cases we see most customers are actually using object storage for today is backup and archiving use cases. So most of the backup and archiving applications of today support to tear data or send data to an S3 object storage layer. So that's one of the most used workloads for object storage, of course, and Cloudbrick is using Cloudian in that manner, for example. Also, we see a lot of content repositories and video surveillance workloads. So these are workloads that generate a huge amount of data that you need to analyze or store or just keep there for a long duration of time. And you want to cost optimize those kind of data, of course. The next, of course, big data. You have applications like Splunk, huge IT environments, or analytics environments, for example, that samples data from many thousand devices, needs to store this in an efficient way, of course, and also Hadoop clusters and other stuff as well, of course. It's literally thousands of applications out there that uses S3. S3 is not kind of a standard, but it's the de facto standard. So all object storage today mainly support S3. That's the biggest of all object storage APIs out there, and applications are developed to be used with Amazon's S3 API. So that's very important to know that not all object storage systems are the same, not the same implementations of S3, of course, but the applications is thousands of applications out there that can speak and use and leverage S3 storage. Of course, Internet of Things, all new things today have some kind of sensors. You see smart buildings, smart cities, smart roads. You see all platform boats. A lot of sensors out there that samples data and need to analyze that, centrally store that, and of course, S3 is the preferred storage for those kind of workloads as well. And of course, it's a lot of service providers out there because not everybody wants to move the data to the public cloud. That could be, of course, because of cost, or it could be, of course, of compliance. So we also see a lot of service providers using object storage systems that can run in their own data center and actually compete with the public cloud as well to deliver a local S3 storage. And this is what Cloudian is all about. We are an on-prem object storage S3 native system. We are scale out, fully API-driven platform, and it's basically just like having Amazon S3, but in your own data centers. And here you can see a bit more like that. So you can see that we tick all the boxes and do exactly the same as Amazon, but it's on-prem. It's not in the public cloud. And this means that you have security of your data. You are fully in control of where your data is located, but you can also integrate it with the public cloud and have the option to send data to public cloud from your local S3 system, of course, if you want to do that. And to put things into perspective, object storage is mainly used for huge amount of unstructured data, like we talked about on one of the previous slides regarding workloads. And at Cloudian, we can start really small. We can start up basically 3 servers with some drives in them, and we're going to show you that today. And you can scale really big to multiple petabyte and exabyte system. And the solution you see over here is actually from the design of one of our customers. That's a worldwide company spreading cloud and object storage system over 20 data centers with 200 nodes per data center, and delivering a huge capacity for their business requirements. So you can start small and scale over time is the beauty of object storage, of course, as well. And we touched up on it, S3. And S3 is not just S3, because it's a lot of systems out there that claim that they can do S3. And of course, they are not lying. But the S3 API is basically combined of a lot of functionality, and it's Amazon's invention. So it's up to us as a vendor to keep track of what Amazon is actually doing with the API and be compliant with that API. And that's why it's really important to be native S3 and use the exact same API that Amazon uses, not have our own API and kind of do a translation from an Amazon API to our own API. Then it's really hard to actually be able to support this. And that's really important because you have applications like Rubrik, like Veeam, like Commvault, Hadoop, and other vendors that do their development to work with Amazon S3. And if you then not are fully S3 native, you can be in the case that you're struggling to actually use some of the functionality because maybe you have 2 out of 3 parts that's requirement for that application to work, but you're missing that last part to really get a great solution. And that's why we at Cloudian natively integrate with Amazon's own API. So if you do a command or API call in Amazon, that API call will be exactly the same in Cloudian. It will be just like working with the public cloud. And of course, not only is the API important, it's also important how you actually are storing the data, how you are protecting the data. Like I mentioned, we can do replication for DR, either to a different Cloudian cluster or different Cloudian nodes. or you can do replication or tiering to the public cloud as well. But you can also do geo-distributed solutions, spreading a Cloudian cluster and object storage cluster between multiple different data centers, for example, or different regions or different countries. And then you have a really great security in terms of logical failures. You can lose entire data centers and still be able to bring out your data and also write new data in the system. So security is, of course, really important. And if we start to look a bit about the technical side, this is an example how a cluster can look like. So in Cloudian, we operate with a topology of regions. So a region, you can compare that to a cluster, basically. And within a region, you can have one or more data centers. So that's physical sites where you have hardware. And within a data center, you will have 3 or more nodes. And as long as your data center configuration is within a region, you can protect data across data centers. But you can also do what we are calling a multi-region system. So let's say this is, for example, Norway, this is Sweden, this is Finland. You can do a dedicated region or cluster for each region, and data will not move across them as native. But you can, of course, enable a bucket to do replication for DR to a different region as well. But you can still manage up to 20 regions within the same management console. So you have one single point of administrating data in different regions, different storage policies for security, and so on, of course. And the way we are able to do this is that we have a true peer-to-peer architecture. So all the nodes in a Cloudian cluster runs all the services at any point in time. So all nodes are equal. But even if all nodes are equal, they can be different in size. So you are actually able to mix nodes with different capacity within a server, within a region or within a data center, and still spread data across all those nodes. And this really means when your application is talking to the object storage system, all the compute power you have in all the nodes in the cluster will bring performance to your application. And it's not a legacy disk storage array underneath and you put some servers on top with some gateways and stuff like that. It's a true implemented service side S3 implementation of the system. And that's, of course, really important to be able to provide scale out, because when you scale out a Cloudian system, you're not only scaling your capacity, but you're also scaling your performance at the same time. So you know what in performance increase you will get when you scale, of course. Data distribution, of course, really important. In Cloudian, we do data distribution at a bucket level. So we are not like some other vendors that say you need to buy 6 nodes, for example, and you can protect this data in this way. If you want to protect the data in a different way, you need to buy another cluster. We are dynamic here, so we can start out with 3 nodes, for example, with what we are calling replication factor 3 fold copies of your data. And down the line, you can add nodes and scale out and change your protection policies to use erasure coding that's more storage efficient instead. And within a region, you can have 1001 different storage policies. So some data you maybe want to protect on a single site, some other data you want to replicate or distribute to 2 or 3 or more sites. So you can control all of this on a bucket level, turn on and off encryption, server-side encryption, compression. You can do different consistency levels. So it's really granular in terms of configuring how you want to protect your data in terms of your business SLAs. What are actually the business SLAs in terms of protecting that data? And if you jump even more down into the system, you can see here how that's actually working with an erasure coding example. For example, with you writing a 60 megabyte object with an erasure coding 4+2, Then we put it into 10 megabyte chunks and protect them across all the nodes in your cluster. So for example, with an erasure coding 4+2, that will be 4 data bytes and 2 parity bytes. You can still lose 2 nodes in your cluster and you're able to read your data, or you can lose one of the nodes and you can read and write data. So we are doing all of this intelligence with our algorithms in backend to balance the cluster, so we are evenly balanced across your nodes in the cluster and all data is protected at all times, of course. And you can even do what we are calling a replicated erasure coding to protect it across 2 data centers. But we are coming more back into this and the options we have in terms of scaling and protection a bit later on here in the presentation as well. And here we can see a kind of an overview of the different methods we can do that. We talked about a bit about replication factor, 3 nodes, that's the smallest Cloudian footprint. Of course, really secure way to protect your data since you have 3-fold copies of your data. You can lose 2 of the 3 nodes and still be able to read out your data. But you're only 33% storage efficient. So if you're storing huge amount of unstructured data, you want the terabyte price to be as low as possible. And that's why customers are looking into erasure coding. And you can compare erasure coding to RAID. So in a RAID, you protect data across multiple drives within a server. But with erasure coding, we are protecting data between different drives in different servers in a cluster. So instead of just doing protection locally in one server box, we are protecting it across all the servers in your cluster. And then you get much more efficient. Then, for example, with erasure coding 4+2, that requires 6 nodes, you're 67% storage efficient. So basically twice as efficient as replication factor with just three more nodes. And we have different ways of doing erasure coding. We can do 3+2, 4+2, 6+2, 8+2. Basically, you can kind of tune this after your needs and after the redundancy level you want in your cluster. You can replicate it, or you can even do geo-distributed. So instead of just writing the data across different nodes, you're writing the data across different data centers, and you can lose an entire data center and still be able to read and write data out of your system. So this sums up our kind of introduction to S3 storage and Cloudian. And the next thing we are going to look at here is proof of concept level. How do you get started with object storage and with Cloudian object storage? So first off, to start, let's look at the hardware requirements. So we have our software can be used both as Cloudian engineered appliances, where we deliver hardware and software to you as a customer, or you can do it in a software only base with building your own hardware on any x86 platform. But of course, we have some requirements in terms of how a node should look like. So for a production environment, you need minimum 2 20-core 2.1 GHz CPUs per server. You need 128 gig memory of minimum, 2 192 terabyte NVMe's or SSDs. This is keeping our operating system that sent us and our metadata database Cassandra. And this is mirrored configuration on those drives, so you can lose one of them and you still haven't lost your entire node. We also populated the nodes with minimum 12 NL SAS capacity drives. They can be from 2 terabyte to how big you want them. In our appliances, the smallest one is 10 terabytes. And you need some network, of course, since S3 is basically a web protocol, it's storage over HTTP, HTTPS. You need some high-speed network, so we require minimum 2 10 gig network ports. And your server hardware needs to support CentOS 7.7 or Red Hat Enterprise 7.7. That's the operating system Cloudian is running on. So that's the production side of it. But you don't need that amount of hardware to do a small POC. And when I talk about a small POC, I'm talking about a small amount of data, getting a system up and running to do functionality testing. This is not for doing performance testing, it's for doing functionality and implementation testing to check that your application actually is working with Cloudian and is working with the S3. What kind of opportunities do you have with an S3 storage? So we deliver this as a VM, a predefined template, and the requirements is minimum 8 vCPUs per VM. You need 30 gigs of memory, one virtual drive with 64 gigs of SSD to the OS and metadata, and minimum 2 times 256 gig capacity drives. Of course, you can add even more capacity drives and more SSD if you want to do a bit larger PLC, but this is the smallest footprint. And in that case, it's enough with one 10 gig Ethernet if you don't want to split out the client traffic and the cluster traffic in the system.
So
we can have a, yeah.
So when you talk about hardware, and the hardware could be sort of any Intel hardware. So even if you have your own preferred, vendor, you can actually choose that vendor if you want to. So you said HP or Dell or whatever, you can use that as well. You don't need to use actually your appliance for that.
Absolutely. We have customers running Dell, HPE, Cisco, Lenovo, Supermicro, Huawei, everything. Name it, we have seen it. So we don't have any kind of connection to the hardware itself. Everything is fully software defined. So as long as you fulfill those hardware requirements and run CentOS or Red Hat on that box, you are able to create a Cloudian node of it.
And probably you want to run Red Hat now because of CentOS is sort of end of life.
Yeah, so CentOS 8 is end of life this year. CentOS 7.7 is going to live on for some more years out, 2024, I believe. So it's not a hurry yet, of course. But that's the state of that at this stage. So here we can see an example of a quite good small POC environment for doing testing and functionality testing. You can bring up 3 VMs in VMware and give them, for example, 8 hard drives. Those hard drives are 2 terabytes each. You can give it 1.92 capacity for the metadata if you want to, but 64 gig is enough. And this will basically create a cluster with 48 terabytes of raw space. And since we are doing the RF3, we are having 15 to 16 terabytes of cluster delivered capacity, since it's 33% efficient. And you will get a stop write at around 30 terabytes. So most storage systems today use what we call a stop write. That is basically to protect you for not filling your hard drives to 100% and fragmentation and stuff like that. So we do a stop write at 90% in the system.
But do you really need 3 nodes to test it all there? If you just want to test the S3 interface, do you really need 3 nodes, or can you use just 1 node?
Yeah, so the reason why we need 3 nodes is because of the system and how we're actually protecting the data. In theory, you can say that you can bring up 1 node, but that will not work for you because our architecture is to actually distribute data across multiple nodes and also get the performance of all those 3 nodes. So the minimum footprint and supported footprint you can do even in a POC is 3 virtual nodes. That's the minimum footprint.
Okay.
And you can see here that it's mentioned a load balancer. So in Cloudian, you don't need a load balancer. You can do DNS round robin, but a load balancer will bring some benefits to you. And one of those benefits is that a load balancer is able to do health checks. So let's say you have your backup application taking backup and dumping that to an S3 bucket. One of these nodes are failing. DNS round robin will not be aware of that node is being down because it's still responding to ping basically. So it will try to send traffic to that node, and you will get a 503 error basically from S3 that because the service isn't running and your backup jobs will fail. But if you use a virtual load balancer, for example, HA proxy, that's open source and free to use, that will do health checks. So it will be aware of that node, that actually that node is in maintenance node or is down or something is wrong with it. And it will not direct the data to that node. It will direct it to the other nodes instead in the system. So we recommend to use a load balancer of some sort. We don't care what type of load balancer you're using. If it's F5 NetScaler, or if it's HAProxy load-balancing.org, we have best practices guides for the most of them. The setup is really easy, but we recommend to do that to be able to do cluster health checks and stuff like that in the system, of course. So that's how you can get started with the Cloudian POC. If you want to try it, talk to the Cristie guys, take a look at the Cloudian website. You can request a trial license and stuff like that.
So you want to have any questions or?
Oh, sorry, I was muted.
Yeah.
So no, not yet. We don't have any questions, so don't be shy. Keep on asking. Please remember that you're invisible to each other, so no one will see your questions. So take it away, guys.
So Ole, if I have a question, is that you talked about a few load balancer there. Is there any special load balancer that you recommend that you think is easy to set up just for Cloudian to do a POC?
Yeah, so we actually see both in POCs environments and actually a lot of production environments as well that customers are using HAProxy. That's open source, like I mentioned. We have a full guide on it, step by step, how to configure that for Cloudian. We have that for F5 and others as well. But you don't want to kind of invest in those kind of expensive load balancer just for doing a POC or a small environment, and maybe HAProxy is enough for you. So we have those guides, and that works really great actually.
Okay.
Yeah, if it's not no more questions, I will keep on continuing. So we talked about the POC. Then we are going into kind of small production, and we're also going to talk a bit about how you can move from that POC and into the small protection situation. So to start off, I want to talk a bit about different options you have in terms of protecting data with a single data center solution. We touched up on RF3 when we talked about the POC with 3 nodes. That will of course be only 33% storage efficient, and you need a minimum of 3 nodes to run that. We also support RF4, of course, even less efficient, 4 nodes. But then we are starting to look into erasure coding, and this is where you really start to see the benefits in terms of price per terabyte and so on. So the smallest erasure coding scheme we can do is easy 3+2, 60% efficient, 5 nodes, of course, is really easy to see what's the minimum amount of nodes is. It's the first number plus the second number, basically data bits plus protection bits. And you can see here this is just some of the predefined schemes that we support. But for example, if you have the need to do, for example, I want to do erasure coding 6+3, you can do that as well. That's no issue because you're just adding parity bits to the system. That will of course affect your storage efficiency, but you're even more redundant, of course, in the system. So this is the standard schemes that we support in Cloudian. You can do even more, but that requires us to take it into consideration when we do the scaling and architecture of the system, of course. So that's basically just have a chat with me, have a chat with the Cristie guys, and we will verify that that's actually a good plan, or if it's not that good to do it, of course. And here we can see a small environment example again. This is based on our own hardware, the Cloudian hardware, and it's basically the production version of the POC environment. So here we do 3 physical boxes. They are 1U. They have 12 hard drives of 10 terabytes. They have 2 of those 192 terabyte or gigabyte 1.92 terabyte capacity for metadata, of course. And that cluster will deliver 360 terabyte raw space. You will get a delivered capacity of one of those nodes, 33%, and you will have the stop write, of course. So this is a really good starting point. So let's say that you have done a POC and you want to put this into production. it's not recommended to run production based on a VMware environment, because what do you most often have in a VMware environment? You have some kind of all-flash SAN, or you're running vSAN, for example, and that's not the platform you want to store your unstructured data. You want that on huge spinning drives that giving great throughput. They are giving great cost into the solution. So what you can do is basically, when you have your POC environment running, we can do what we are calling an add node, and we're going to have a slide on this a bit later. And you can add the new physical nodes into the cluster. The cluster will rebalance and move the data over, and you can basically then just remove the virtual nodes, and you have migrated your entire POC environment that you was running over on the new physical hardware, even if that's some third-party vendor, or if it's Cloudian nodes, that doesn't matter. The functionality is still the same, and you can even continue to use that virtual load balancer if that's sufficient for you, or you can spin up a pizza box with HA proxy on that, or some kind of other load balancer as well. So it's really easy to move from that POC setup to a physical setup for production. When you actually are able to push on performance to the cluster, you can do the real scale out and have a real production environment. And if we take a look at another setup, for example, you can do in a small system, you can do, for example, a small footprint of 5 nodes and do ratio coding 3+2. And like I mentioned here, we can see the storage efficiency is much better, because we are protecting data not with full copies, but we are splitting it up like we do with RAID across the nodes. And you can still do that migration from that POC environment and move over to this environment. And you can continue to scale this environment with adding nodes to the system. And this looks a bit like this. So let's say you have a...
If you go back, so basically is that if you're moving from an RF3 environment into RAID coding, can I reuse the space? So let's say if I migrate the data from the RF3 over to erase coding, is that I'm just migrating data and then sort of deleting my replication factor 3?
So what you're doing, let's say you have that data is stored in a bucket with replication factor 3, and you have added the node to the system. You have enough nodes to do EC3+2, for example. You will create a new storage policy and create a new bucket, and then you will migrate that data over to the new bucket, and then you can just delete the old bucket, the RF3 bucket, for example. Or you can use the built-in functionality in the system to enable tiering between those buckets. So then you can see that all the data is moved over. You don't need to use some external tool to move that data. And then you just do the switch in your application and delete that RF3 bucket.
And that will not change anything from an endpoint perspective. So the application will not...
The endpoint will need to be configured with a different bucket name. It will be, because you're changing the bucket.
If I tearing the bucket only.
Yeah, then you can still keep the RF3 bucket as your front end bucket and just do the tiering in backend and have it connected there. But of course, then you're first writing the data as RF3 and then converting it to EC3+2 in backend. So you can do that. It's nothing stopping you from doing that, but it's not. It depends on the use case. What's the best practice and what's actually the application is able to handle or not. But both options are absolutely valid. And if we look a bit at that scaling, so here we have a cluster with some nodes running. You can add a single node at a time to the cluster, and the cluster will rebalance. But even if you can add a single node at the time, that doesn't mean that this is always the best practice. So what we do when a customer wants to scale the cluster, we have a tool that actually are simulating the add node and the scaling of the cluster. And based off that, we are optimizing the algorithms. We're seeing if it's smart to scale with one node, or if that means that if you scale to one node today, you basically need to scale with another node in 2 months or 3 months or 6 months because of your growth rate. So we are always trying to help our customers scale in the best possible footprint at each time to be cost optimized and actually have a nice and balanced cluster as well in the system. With the small footprint you can scale with, it is one node of the time. We often see that customers are scaling with 2 nodes, for example, or even more. It all depends on the use cases they are doing. But it's some best practices there.
So that's actually really good. If you compare with other S3 vendors, they normally like double the nodes for every single time, basically.
Yeah, and this all comes down to the granular storage policies, because many other object storage vendors are kind of locked. If you start out with EC4+2, your cluster will be stuck at EC4+2, and when you scale, you need to add 6 more nodes. But since we are granular there, we can have multiple different ways of storing the data and protecting the data. You are able to scale with basically from 1 to how many nodes you want at a time. That will look a bit like this. So if you're running EC3+2 and adding node number 6, you can of course continue with EC3+2, and it will be a capacity expansion. The algorithm will spread the data across all the 6 nodes. But even if you want to, you can go from those 60% efficiency with EC3+2 and do EC4+2 instead and get 66% efficiency. Or they can coexist as well, that you keep your old data at EC3+2, but you want to put some new kind of workload on EC4+2 instead to be even more storage efficient. And this just continues when you add nodes. So let's say you are adding, so you have 8 nodes in total, then you can do EC6+2 and be even more storage efficient, 75% storage efficient, or 8+2 and be 80% storage efficient. And this just continue with the lifespan of the cluster. And even let's say you have run this cluster for kind of 5 years, you need a hardware refresh. You will basically add your new nodes first. The system will rebalance, move data into those nodes, and then you will trigger a node uninstall on the old nodes and taking those old nodes that you need to throw away because the port is run out, it's old hardware and stuff like that. And you have done a total hardware refresh of your cluster. So it's really simple to manage in terms of expansion, lifecycle management, and so on in the system, of course. Now it's questions.
One.
Yes, I have a question here. Can we reuse the load balancer from the POC to a single site, and can it be virtual?
Yes, it can. Of course, you need to be aware of the scaling of your load balancer. Of course, if you've done a small POC with a small poor load balancer and you move into production, of course you will need to scale that virtual load balancer or that physical load balancer in terms of being able to handle the throughput requirements you need for your production environment. But it's really easy to do that and just keep the old load balancer and put it into the system, add some extra networking, add some extra memory, maybe a bit of CPU, and just scale that after what you need and what your requirements for performance are in the system. So that's absolutely possible. We have many customers that have done that.
Okay, thank you. And another question is, can I run my production workload in a virtual environment?
No, so like I mentioned, it's not recommended because often you have expensive storage in your virtual environment. You often have all-flash, pure storage, 3PAR, vSAN, and stuff like that. And that's not where you want to store your backup. And also the backup you're taking, for example, is often from that same environment. You want that externally. And the cost will just go up with it. Technically, it's fully possible, but it's not recommended to use that. And VMware will add an extra cost layer there as well, of course. VMware is not cheap. It's amazingly good software, but it's not cheap. But what we recently announced together with VMware is the support for Cloudian Hyperstore running as Kubernetes containers in VMware Tanzu. So if you are running VMware Cloud Foundation and have Tanzu, you can go into your VMware console, push a button, and you will deploy a fully Kubernetes-based Cloudian cluster that's for small big DevOps environments and edge computing, not for storing huge amount of backup storage or archiving storage, but for modern applications and stuff like that. So that's the use case for running cloud and virtualized as of today.
Okay, thank you.
Any more? I think I can see.
Yeah,
how long does that
one more question
take? Yeah, if you can take that one.
That is, we have a question about Veeam on this, and I think we should refer a little bit to say that if you're running Veeam, they have a sort of warm technology that could push into AWS to be ransomware protected. Can we use that as well with Cloudian, and can I try it out on a POC level and also from a single site solution?
Yeah, so I can answer that quickly. We're coming a bit into that, but the question to all of it is basically yes. You can try it in a POC. Of course, you will not get any good performance on your backup in a POC, but to test the functionality, that's absolutely possible. You can run it on 3 nodes in a single site if you want to do that. And since we are S3 native, we deliver exactly the same functionality that Veeam does with Amazon, but on-prem. And Cloudian was actually the first vendor to be certified for that functionality with immutable backups with Veeam.
Okay. And we also have another question here.
Yeah.
How long does the cluster rebalance take, and how does it impact performance? If you compare with like RAID, or especially when you're running RAID with large disk, it could actually impact about the performance, and especially the rebalance could take pretty much forever.
Yeah, so this all depends on how much data do you have. So basically, yes, rebalance can take some time. If you have a cluster with multiple of petabytes of storage, it's of course a huge amount of data that are going to be rebalanced. But this runs in background in Cloudian. It has dedicated resources for it, and we are making sure that it doesn't impact the performance of the cluster in the front end, because it's dedicated resources for that algorithms to run that rebalancing in the cluster. But of course, it can take everything from minutes to hours to days. Basically, all depends on how much data you have in the cluster. But all the nodes in the cluster are pitching in to deliver performance. It's pin performance for the rebalancing, so it doesn't eat out of the cluster front end performance basically. So it's really efficient, and we're working all the time to improve it even more. In our latest release 74 that was launched 2 weeks ago, we improved it a lot actually with the rebalance, and we are working even more to kind of optimize it all the time to get it better and better and better. But yes, it can take some time in huge environments. It can.
And I think all that this is actually really common in eraser coding format, that eraser coding is more built up for performance. It's actually always deliver performance, and the rebuilding is sort of the second hand. And because you have it streamed out on so many nodes, it's actually it doesn't really matter if it takes days or weeks to rebuild. It's more important to great performance and always have the data available.
Yeah. Absolutely. Since all your data is protected across multiple nodes, it doesn't need to go really quick, basically. And it's the law of physics. How fast can you transfer data across your network? And how fast are a spindle drive able to write that data is kind of your limitation. But just like you said, it doesn't matter if it takes hours or days, basically, because you have your data protected. You are using all the resources that are available for you. And that's one of the great benefits of being a true scale-up, true peer-to-peer system, that you don't have some kind of S3 translator nodes that translating the data into legacy kind of technology on the disk side in backend.
And that's actually interesting, because that could take us to the next topic, is actually scaling and scaling up. Because if you are afraid of losing data, you're probably looking to scaling up to a multi-site solution that we are on the next topic.
Yeah, absolutely. So this is talking about the disaster recovery, multi-site implementations. and stuff like this. And like I mentioned in the beginning, you can start out small with that single data center, and over time you can expand to data center number 2, number 3, number 4, and so on, and live and build after what your business requirement is, basically. So again, 2 data center protection, you have the sheet here in terms of the protection. You can see the erasure coding is dropping down because you're doing a full replica of that data. So it's cut in half basically, and it requires twice amount of nodes because you need 2 equal sides to do a full replica. But it's still a great solution to be able to have that DR in terms of if you're losing connectivity to your first data center, if you have a fire, earthquake, everything you can imagine, you need to kind of protect your data on a secondary site, and we of course support that natively in Cloudian. So here you can see an example with 12 nodes across 2 data centers and replicated erasure coding 4+2. Unfortunately, since it's replicated, you are down to 33% efficiency. But you have a really highly secure platform. Even if you lose one of those data centers, you will still have data available on the other one, and you can write data into both solutions. This is cross-replicating. So if you have an application in data center 1, that will write the data into data center 1. If you have an application that needs to read that data in data center 2, you can read that out from data center 2, for example, to always ensure the fastest path to the data itself. And you can expand this, of course, as well. Like we did with a single data center, you can easily add 1 or more nodes. And of course, you need to add that to both data centers because your protection policy is basically saying that you are doing replicated. But even if you're doing replicated on some data, maybe you have some data you just want single site protection on. And that's the beauty of the granularity of the storage policies, again, that some data might be replicated, some data might just be stored in data center 1, and some data might just be stored in data center 2. So you can mix and combine these storage policies within the same system. And that's really good. So we see a lot of customers running the replicated. Of course, it's really secure, but it really goes out on your cost per terabyte. It's not the best on your cost per terabyte. And that's why many customers are optioning for the 3 data center protection. So if we're talking about distributed erasure coding, here is actually where we require the minimum amount of nodes, getting some of the best efficiency and really resilient system. Here we are talking about 99.14 nines in terms of logical failures with erasure coding 7+4. And actually, if you compare that to...
So why can I not run like 8+2? What happened then if I run 8+2 in a three data centers?
So 8+2 basically doesn't fit into a 3 data center system because you need a minimum. For example, you need a minimum of 3 nodes per data centers, and if you have only 2 in parity, if you lose 3 nodes, then you will lose data because you don't have enough parity in that system. So you need parity of 4 or more to run in a 3 data center system. You need to be able to lose either 4 nodes in a 12 node setup. That's an entire data center, or you can lose 3 nodes and 1 node in a different data center with EC5+4, for example, and still be able to read and write data in the system. So it all comes down to the parity, number of nodes, and how you protect that data. So the minimum in a multi or 3 data center or more configuration is basically 4 of parity, 4 nodes of parity in that system. And back to what I was saying, if we look at the resiliency, 99.49, Amazon S3 delivered 99.11. So we can actually build a more resilient solution with Cloudian on-prem than Amazon actually can guarantee you in the public cloud as well. And here we can see one of the examples running with 9 nodes, EC5+4 across 3 data centers. Remember, if we want to run just 2 data centers and replicated EC4+2, we need 12 nodes and get 33% efficiency. So here you can spread the data across 9 nodes, 3 data centers, lose an entire data center, still be able to read and write data, and you get 55.5% efficiency out of it. So it's really storage efficient, it's really secure, and this is where we see most of the service providers and enterprise customers ending up when they're building a Cloudian solution, because they want the data availability, they want the lowest price per terabyte or gigabyte or petabyte, of course, and they want an easy to scale, simple to manage system. And
is there any latency between them that you need to have?
One more time.
Any latency between that, the minimum latency between those data center or maximum latency, should I say?
Yeah, so basically, if you're doing a 3 data center or more system with distributed erasure coding, you need to have a maximum 10 millisecond round trip between the nodes in the data center. So maximum 10 millisecond round trip. We are lucky here in the Nordics that most of us have really good connections into the data center, so it's usually not a problem. We don't often see that problem. That's only if you're trying to build a solution spanning from Sweden to the US and to China, for example, then you probably need to replicate it instead, or doing a cross-region replication. But here in the Nordics and in Europe, we don't often see those problems being an issue. And again, easy to scale. You can actually add 1 node of the time. And let's say you are a customer, you want to start using Cloudian, and you buy in on a small footprint with 3 nodes with RS3, and you see that we have a lot of use cases for it. We are getting a lot of business requirements. We need a true scale-up system. You can keep those 3 first nodes, buy 6 more nodes, place them in 2 different more data centers, and jump straight from that POC environment or small environment with a single site 3 nodes and move straight over to the 3DC. Or you can go from 1 data center, scale out that, add a secondary data center, scale out that, add the 3rd data center, scale out that, and just keep adding data centers as well, getting more and more redundancy, getting more and more performance, more and more capacity, and just live with your system and do a real scale-up solution. Any questions?
Yes, we have. How do we monitor performance and capacity in the system?
Yeah, so with Cloudian, we have the Cloudian management console that runs on every node. You can get some data from that, but actually recently, last summer, we also announced our monitoring and analytics tool called HyperIQ. This is an application that runs outside your system. It runs as a VM or as a container or on your desktop, and it continuously talk to the system and gathering metrics and data and doing analytics both in real time and historic data from your object storage system. So it's a really nice, easy to use monitoring system, and that of course also do alerting and stuff like that.
And that is, if I don't remember wrong, Ole, that is based on Grafana, isn't it?
Yeah, it's based on Grafana and Prometheus with a customized dashboard on that for Cloudian, so you can monitor everything from capacity, performance. You can drill down into each of the services the nodes are running in terms of uptimes, memory usage, performance usage. You can take a deep dive into the metadata databases and stuff like that. And we are adding new functionality all the time, actually. So we are looking into building in even more analytics into that to integrate it with TensorFlow or other applications or Elasticsearch and stuff like that to be able to search and metadata stuff like that in the future as well.
Okay, thank you. Another question. If I have a Cloudian cluster, how do we upgrade the cluster with new versions?
Yeah, so that's quite easy. So all the updates in a cluster and all expansion are non-destructive. Since all nodes are equal, we can trigger the updates and expansions from one of the nodes in the cluster, and that will be the upgrade master node at that point in time. It could be any of the nodes that you trigger that from. and it will do a rolling update of the software in the cluster, doing node per node, keep making sure that enough services and enough nodes are always running, so we can still deliver data and access to the data in the cluster. And even if it fails on one of the nodes, it will do a controlled rollback in the system. So it's a customer upgradable system that's really easy to upgrade.
So Ole, I know we start running out of time, but we have one more topic. We need to go into that.
Yes, absolutely. That's
actually a really important one, and we're going to have another session on that. Just focus on security and application uses of Cloudian. But if you're given a hint, how does the security work really in Cloudian?
Yeah, so security is of course really important for us. We have a lot of financial military customers as well, so we have some certification that we need to do. So we support all the things you expect us to support, like role-based access. We do HTTPS, we do audit logging, we can do encryption and stuff like that. And we also have our VERM functionality that we use with, for example, immutable backups with Veeam. And if we do quite a quick look into that one, is basically we do a lock on that object on the object itself. So when, for example, Veeam writes the data into the bucket, the Veeam is actually setting the policy. So Veeam is telling Cloudian, this object you can't edit or delete it before the retention runs out, and that will be enabled with the S3 object lock API to actually lock down those objects in the system and creating a immutable and ransomware protected solution.
Actually, you're coming into that. I was just asking, if you lock in your object and because you have a Linux operating system, is it possible that maybe someone is coming in and erasing the data anyway from?
Yeah, so when you enable object lock, we require you to use what's called type-store secure shell. We always recommend to use customers to use this anyhow. It's working both on our appliances and on software only based on whatever hardware. And this is basically locking down and hardening the CentOS or Red Hat operating system you're running, disables the roots. You can have multiple admins into that, and it's actually creating a shell UI on top of the CLI. So you don't have file level access to the operating system longer. You can only run pre-certified scripts and application and menu options that are certified and security certified by Cloudian into the system. And we also do full shell logging for that as well. So we do audit logs that we can provide you as well.
But is it a good thing to start already from the beginning?
Yeah, so I recommend all customers to start with this from day one. Usually our professional services and partners install this with the customer and do that from day one to start and have that strict lockdown of the system, of course. So that's the last slide on security. Of course, we're going to have another deep dive session on security. It's a topic for itself, like you mentioned.
Yes, we have another question. Is the support handled by Cristie or Cloudian?
I think that is more my perspective to answer, but we can actually have both. So if you want to have it as a service, Cristie take care of the support and help you out, and we can do a full managed service on it. But if you buy it as an appliance and own it on your own, the support take care of our Cloudian.
Yeah, and of course, always in background behind Cristie's service, Cloudian support is there anyhow. So they have support from us again, and we are running fully 24/7, 365 support. We do spare parts, we do everything from our end again. So it's enterprise support on this, of course.
So any more questions, Johan?
No, that was the last one.
So from here, we're right on time. I was a little bit worried about all the slides. We'll get it covered in an hour, but we did. So Ole and everyone, thank you for this Tech Talk, the first Tech Talk. And we will of course record this and put it on the website if you want to follow up later on or listen again to it. So again, thank you, have a great day and enjoy your lunch.